Okay, class, in this lesson, we are going to learn four things. Number one, you're going to understand the difference between a variable and a unit. Number two, you're going to know the importance of unit measures, especially in science. Number three, you're going to be able to convert from one unit measure to another. And then number four, you're going to be able to rearrange an equation to find the unit measures of a variable. Okay, so let's go ahead and get started. All right, so what is the difference between physics and math? Well, the main difference between doing math in a math class versus doing math in a science class is that in science we use units or unit measures that follow after we come up with an answer, which is typically a number. Now, the reason that unit measures follow a particular number is because they give numbers meaning. So what does that mean? Let's take a look. Well, anything that can be measured has to have a unit of measurement, okay? So for example, I am 5 feet 6 inches tall, or a paper is 8.5 inches by 11 inches. Cars travel on average 70 miles per hour on the freeway, and water boils at 100 degrees Celsius. Okay, so in that first example, I am 5 feet 6 inches tall. If I just said I am 5'6", you may not understand how tall I am. Although in this country, we all assume that's 5 feet and 6 inches, 5 feet 6 inches. But for people outside of the United States, they may not understand if you say I am 5'6". Or, for example, if we ask what is the dimension of that paper, you might say it's 8.5 by 11. Is that inches? Is that centimeters? You know, what is that exactly? We know paper to be of standard length and width, and we know it's 8.5 by 11 inches. But for others, that may not be clear. And if we're talking about, let's say, a piece of paper that's 4 by 6, do you know that it's 4 inches by 6 inches? Or 4 centimeters by 2 centimeters? Or even 4 feet by 6 feet? So without unit measures, it's very difficult to understand what those numbers mean. So the numbers we use in our calculations have to have meaning, right? We can't just throw numbers around, as I was saying earlier. So if you said I paid $100 for those shoes, well, did the shoes cost $100? Or did you pay it in 100 quarters? Okay, so without unit measures, numbers have no meaning. So in this class, it's going to be very important that when you calculate something, you're going to go through all of that work to come up with the correct number. But if you don't have a unit measure, that problem is going to be wrong. All right, so let's go through a couple examples here. What do you think is the unit measure here? I weigh 150. Most likely it's going to be pounds, okay? I am 60 blank old. I am 16 years old. My height is 5.8 feet. His height is 156 centimeters. The distance from Corona to Riverside is 22 miles. And then it takes 2 blank to drive to San Diego from Corona. We would say 2 hours, okay? So as you can see, when we put the unit measures in, it gives the numbers context and meaning. So now we're going to switch gears and ask the question, what is a variable? Okay, a variable represents a value or a number for which we solve. Okay, scientists use letters from the alphabet, and you've seen this in math class. They'll use X or Y. Sometimes you go to Z, and there may be other letters. Or in math, you may use Greek alphabet such as alpha, beta, and delta to represent variables instead of writing the words every time. For our physics class, we will use variables to represent various parts of an equation to solve for things like energy, velocity, force, momentum, etc. Okay? So here's an example. The density of an object equals the mass divided by volume. Okay? The density, this is the first variable, is equal to the mass of an object, that's the second variable, divided by the volume. That would be the third variable. Okay? So for example, if the mass of a liquid is 100 grams, so we would put that 100 grams here in the numerator, and its volume is 5 milliliter, so that's 5 milliliters in the denominator for the volume, then its density is going to be 100 divided by 5, which is 20, and then my unit measure is just grams divided by milliliters, or grams per milliliter. Okay? All right, now we're going to talk about identifying units and variables in this particular example. Okay, so here's the statement. Granite has a specific heat of 800 joules per grams degree centigrade. What mass of granite is needed to store 15,000 joules of heat if the temperature of the granite is to be increased by 15.5 degrees centigrade? Okay, we're not going to solve this, but what we need to do is highlight every number and its corresponding unit. Okay, so let's go ahead and do that. We're going to highlight every number and its corresponding unit. So the first one is 800 joules per grams degree centigrade. The next one is 15,000 joules. And then the last one is 15.5 degrees centigrade. And then the next question is, what is the variable the question is asking you to find? And then what is that unit measure? Okay. So if you take a look, the question here is what mass of granite? Okay, so we're looking at the mass of granite. Okay, and the unit measure is going to be in grams. Now, how do I know that? How do I know that it's in grams? If you take a look at all of these unit measures, okay, the only unit measure that has anything to do with mass is right here. This is my grams, okay? And therefore my unit measure is going to be grams. Okay, now let's take a look at 4 variables. And the first one we're going to look at is length, okay? Length is the distance between 2 points. I think everybody knows that. In physics, the base unit for length is going to be meters, okay? Represented by the symbol m. Now, if we look at some big numbers, okay? 1 meter, we have 1 meter. If we have 10 meters, that's called a decameter, okay? So every 10 meters is a decameter. If we go to 100 meters, 100 meters would be equivalent to 1 hectometer. And then if we go to 1,000 meters, which is this right here, now we're looking at 1 kilometer or kilometer, okay? Now if we shift gears to the smaller numbers and we start with meters again, 1/10 of a meter or 0.1 meter would be equivalent to 1 decimeter, okay? And then 1/100th of a meter would be considered centimeter, and then 1/1000th of a meter is 1 millimeter, okay? So this means that we need 1,000 millimeters for it to equal 1 meter. We need 100 centimeters to equal 1 meter, and then we need 10 decimeters to equal to 1 meter, okay? It's really important to understand all of these moving forward because we will be using this quite a bit moving forward. All right, now let's shift gears to mass. Mass is the amount of matter in an object, okay? The base unit is gram, or the letter G. So for example, 1 kilogram is equal to 1,000 grams, and then 1 gram is equal to 1,000 milligrams, okay? Now, you can think of mass as quote-unquote equivalent to weight, but it's not the same, okay? Weight is different on Earth versus the weight of a particular object on the moon, okay, as an example. So if you think about an astronaut. The astronaut has a particular mass, okay? And that astronaut will weigh anywhere between 150 to 200 pounds, for example, on Earth, okay? But the same mass on the moon will weigh less. And the reason for the difference is because of the gravitational pull or gravity between the Earth and the moon. And this is why we don't use weight as a way to determine mass, because mass is, again, the amount of matter in an object, okay? And that doesn't change from one location to another. Okay, now let's look at volume. The volume is the amount of space occupied by an object, a 3D object, okay? That could be a thing, it could be a liquid, it could also be gas. And the base unit in physics for volume is going to be in liters, okay? And that's represented by the letter L, and it's a capital L. So for example, 1 liter is equal to 1,000 milliliters. Okay, and then the last variable here, we're talking about time, and I think everyone's familiar with this. Time is the interval between events. Okay, so from one event to another, that is the interval, and that is measured by time. It's also the measure of change. So when there's a chemical reaction from the beginning to the end, we would say that there's time that elapses, and that is a measure of change. And the base unit for time in physics will always be seconds, and that's represented by the letter S. Okay. Now here are some equivalencies that you should be aware of. 1 year is equal to 365 days. 1 day is equivalent to 24 hours. 1 hour is equivalent to 60 minutes. And then 1 minute is equivalent to 60 seconds. Okay? We're going to need to know this later on in one of the examples. All right, now, unit conversion. Okay, this is a topic that a lot of kids get confused with. And so what I'm going to do is show you some basic steps to follow when you're converting from one unit measure to another. Okay, now let's go ahead and define what we mean by unit conversion. It is the process of changing the unit measure of a physical quantity without changing its actual values. Okay, so it's like saying $1 is equivalent to 4 quarters. It's changing the quantity. $1 is one single bill, and 4 quarters is four quarters, but the value is still the same. And so that's what we're going to do with a unit conversion. Now I've outlined the steps that you should follow to convert units. Okay, so you want to write down your starting value and its unit. So whatever is given to you, you start with that. Then, this is the hardest part, you're going to find the relationship between the old unit and the unit that you want to go to. Okay, in some cases, you might have to take 2 or 3 or even 4 steps to get there. But you start with the old and then do the conversion to the new. Then you're going to build a conversion factor with the target unit on top. Okay, it's going to be on top. And then the current unit on the bottom. And then lastly, you're going to multiply the numbers and cancel the matching units. All right, so I'm going to go through 6 examples so you can see how this works. Okay, so first question is, how many feet are in 12 inches? Now, many of you will automatically know the answer without doing the calculation, but I want to show you something that you already know the answer to and walk you through the calculation. Okay, so the first thing you're going to do is start with what is given to you. So we have 12 inches. Okay, then we're going to multiply this by a conversion factor. And I said earlier, this is the hardest part. So you need to know how many inches are in a foot. And you know that there are 12 inches in a foot. And so we would say there's 1 foot for every 12 inches. Okay? And then when you go ahead and multiply these together, you'll notice that this will cancel out, that's going to cancel out, this is going to cancel out, that's going to cancel out, and then your answer is 1 foot. Okay, which is the answer you already knew. But here, this is the unit conversion process that you're going to go through, and this is the process you're going to follow for every unit conversion. And if you follow this method, it will make unit conversion much, much simpler. Okay, let's go to example 2. How many quarters are in $7? Okay, how many quarters are in $7? So again, we start with what we have. We have $7. Okay, and then the hardest part is identifying the conversion. How many quarters are in $1? There are 4 quarters for every dollar. Okay, and if we go ahead and multiply this out, you'll see that the dollars cancel out, and all you do is multiply this across. 7 times 4, we get 28. And the only thing that's left is quarters. Okay, I think I misspelled that. Let's go ahead and fix it. Quarters. All right, so we have 28 quarters. Quarters don't get canceled out, and so this is our answer. There are 28 quarters in $7. All right, hopefully this is starting to make sense, and it should be fairly straightforward. Let's take a look at example 3. How many feet are in 2 miles? Okay, how many feet are in 2 miles? So let's start with 2 miles. Then the conversion factor, which I said was the hardest. You need to know that there are 5,280 feet for every 1 mile. Okay, and if we go ahead and multiply this out, we see that the miles cancel out, and all we do is multiply 2 by 5,280, and that gives us 10,560 feet. Okay, so this is our answer. All right, let's move on to example 4. How many minutes are in a day? Well, let's start with what we have. What we have is 1 day, and we want to know how many minutes there are. Okay, so this is where we're going to go through a couple different conversions. So we need to multiply this by the number of hours in a day, which is 24 hours in 1 day, and then we have to continue to convert how many minutes are in an hour. Well, that is 60 minutes are in every 1 hour. Okay, now I'm going to pause here for a second. You notice that I put the hours up here and the day down here. Okay, I could put the day up here and the 24 hours down here, but the reason I want to put day on the bottom is because I want to cancel this out. Okay, same thing with this. I could put the hour up here and the minutes down in the denominator, but because the hours are up here, I want to get that canceled out. So I need to put the hour part down here. And what I'm going to be left with are minutes, which is exactly what we're looking for. Okay, now if you go ahead and multiply this out, as I mentioned, the days will cancel out, the hours will cancel out, and now all you do is multiply these numbers together, and that works out to 1,440, and then the unit measure that's left is minutes. Okay, 1,440 minutes. All right, let's move on to example 5. How many grams are in 43.12 kilograms? Okay, again, we start with 43.12 kilograms. That's what we know. Then we have to go through the conversion factor. Well, we need to know how many grams are in a kilogram, and that is 1,000 grams per 1 kilogram. Okay, so we have a kilogram down here, kilogram down up there. We can go ahead and cancel those out. And now we're left with 43,120 grams. Okay. Okay. Even though I said it correctly, I wrote it wrong. My apologies. 43,120 grams. Okay, and let's move on to our last example. How many liters are in 7,110.5 milliliters? So again, we start with what we're given, 7,110.5 milliliters. Then we're going to go through the conversion factor, and that is 1 liter is equivalent to 1,000 milliliters. Okay, the milliliters will cancel out. And now our answer is going to be 7.1105 liters. Okay? All right. Hopefully that made sense. If you have any questions or something wasn't unclear, please go back to the beginning of the recording and listen to it again. Thank you.